Hello everyone. This video would focus on graphing sideways parabola or sleeping parabola in vertex or graphing form. And this is the second part. In this part, the absolute value of A is greater than 0 and less than 1. Before we go further, please feel free to check out the description below for the link of the other series of topics related to graphing sideways parabola or sleeping parabola. Before we jump into this example right here, let's have the basics on sideways parabola or sleeping parabola in vertex or graphing form. We remember that the vertex form or the graphing form of sideways parabola or sleeping parabola is given in an equation x equals a parentheses y minus k squared plus h. Now let's look at the effects of the parameters a, h, and k to the graph. So this is the graph of a sideways parabola or sleeping parabola. We remember that if a is positive, the parabola opens to the right. As you can see, this graph opens to the right. Now if a is 0, the graph is a vertical line. On the other hand, if a is negative, the graph opens to the left. On the other hand, we also remember that if the value of a gets closer to 0, the graph becomes vertically stretched. So you can see the graph becomes more and more vertical until up to a point that at 0 it becomes a vertical line. On the other hand as well, if we start from 10, then we go towards 0. We change the value of a towards 0. We can see that the graph again becomes vertically stretched. That means it becomes more and more vertical up to a point that it turns into a vertical line when a is 0. On the contrary, if the value of a gets farther from 0, so right now it's a vertical line. If we go farther from 0 towards the positive 10, the graph becomes horizontally compressed, meaning it becomes more and more horizontal in shape as we go farther from 0. This is also the same thing if we go the other side. So if we start from 0, which is a vertical line, if we go or if we change the value of a away from 0 towards negative 10, the graph becomes horizontally compressed, meaning it becomes more and more horizontal in shape. We also remember that the coordinate hk is the vertex of the graph, or we sometimes call this as the locator point. So this one right here is our locator point. Now we remember that the k is the parameter that translates the graph up or down, while the h is the parameter that translates the graph left or right. Okay, so we go over the problem here. We're supposed to sketch the graph of this equation, and the first step that we have to do is to determine the vertex or the locator point. So I'm going to go ahead and write it down here. To determine the coordinates of the vertex or the locator point, we are going to use the hk value. We remember that for sleeping or sideways parabola, this will be our h and this will be our k. And our k shall be switched. The sign of the k should be switched. So in this problem right here, we can go ahead and say that the vertex or locator point is located at 7, and then switch this, that's negative 3. Now let's move on to the second step. We are supposed to create and complete the table of values. I'm going to go ahead and write that down here. We are going to place the vertex or locator point in the middle. So this is where the 7 and negative 3 is going to sit. And so we go ahead and determine the values for y. Since this is a sleeping parabola, we are going to determine more values of the y. So from negative 3, it can go down to negative 4, then negative 5, then go up to negative 2 and negative 1. Our task then is to determine the x. So that's what's missing, or it's by itself on the left side of the equation right here. So we're going to solve for x. So we are going to show the work on the side right here. So what we would do is we are going to plug these, let's say this -2 right here, y. We're going to plug it into the y and we're going to solve for x. So I'm going to go ahead and show that work up here. So when y is equal to -2, we're supposed to solve for x. So I'm going to go ahead and write this equation here. So what I did here was I left this blank, and instead of writing y, we're going to put the -2 here. So I changed the 1/4 to decimal form, that is 0.25. And so from here, we can go ahead and solve for our x value. So this is -0.25, and then this is -2 plus 3 is +1, and then we square it, that's +7. So this would be -0.25. 1 squared is 1, then +7. So this is -0.25, because when we multiply this, it's a -0.25 plus 7. So the answer for this would be +6.75. So I'm going to go ahead and write that value up here. So 6.75. Now I'm going to show the work when y is equal to -4. So I'm going to show the work on the side right here. Okay, so let's explain this part right here. So as you can see, we have a -4, so I plugged it into the y. So -4 plus 3 is -1. -1 squared is a +1. Please remember this, because others are going to think that they're going to multiply the negative and the negative. It makes it positive. That's not how it works, because remember, this is an exponent, so it has to be simplified first. The exponent should go first. So -1 times -1 is a +1. Multiply it with a -0.25. So that's how we got here. So the final answer for this is 6.75. So I'm going to go ahead and write that down here. And so I'm going to show the work for y is equal to -1 and y equals -5 down here. So this is how it's going to look like. Okay, so what I did here was we have a -1 plus 3 is a +2. When we square it, it's 4. And so we did the math and it's 6. In this case right here, we have a -2. Remember, we are supposed to square it first. So -2 times -2 is a +4. And then it turns out to be 1 because we multiply that with -0.25. So that's -1. And then plus 7 is 6. And so I put that on the table, and our next step is to sketch the graph. So we're going to start by putting in the vertex that's going to be on +7. It goes down to -3. So that's going to sit right here. So that's 6, 1, 2, 3. So this is our vertex. Our next dot is on 6.75. So that is 6.75 should be somewhere around here. And then it goes with 4. So 1, 2, 3, 4. So it's going to sit here. And then our next dot is on 6. It's going to go with -5. So this is our next dot. And then we also have 6.75. So go back to 6.75. And then we have a -2. So it's going to sit right here. And then we have 6 goes with -1. So it's going to sit here, so that we can go ahead and sketch the graph. Okay, as you can see here, this graph is going to the left towards infinity, and it starts on x equals 7. On the other hand, this graph is going upward towards infinity, and it's going to go down towards infinity. This tells us that our domain for this would be values that are less than 7, and the range for this would be all real numbers. So I'm going to go ahead and write that up here. Okay, so the domain would be the values of x that are less than or equal to 7, while the range should be all real numbers going up and going down. Now let's move on to the next example. At this time, I would encourage you to pause this video and try this problem out on your own. And when you're done, unpause it and check your answer. Okay, so we go over the problem here. Again, our first step is to determine the vertex or the locator point. So I'm going to go ahead and write that down here. Okay, so our vertex or locator point is located on -8 and +3. Remember, the h will be kept. I kept it negative. And then this k will be, we switched the sign so that came out positive. Our next step is to create and complete the table of values. I'm going to go ahead and write the table of values down here. Okay, what are we going to do is we are going to complete the y values. So we can go ahead and go up to 4 and 5 and then 2 and 1. And then from here, we can go ahead and solve for the x because these are all the missing ones. And in the equation, we are having x by itself. So we can go ahead and plug in the value of y into this equation right here and solve for x. So I'm going to go ahead and show the work on the side right here. Okay, so what I did here was that I determined the value for x by using the value for y that were determined at the beginning. So then we go ahead and explain this part right here. So 4 minus 3 is 1, and when we square it, it's 1. So that's how we got -7.5. Here is a thing where most students would miss. We have 2 minus 3 is -1. When we square it, that's a +1 because we have a -1 times -1 is a +1. And so that comes out 0.5 and then subtract 8 from it. So that is -7.5. The same thing for the other side right here. So this one right here becomes 2 because we have 0.5 times 4 is 2 minus 8 is -6. This one where most students would miss, 1 minus 3 is -2. -2 squared means -2 times -2. That comes out +4. +4 times 0.5 is a +2. Minus 8 is -6. And so we completed the table already. We're now ready to sketch the graph. Okay, so we go ahead and sketch the graph for this equation. So we have -8 goes with +3, so it's going to sit right here. We also have -7.5, so this is -5, -6, -7.5 goes with 4, so it's going to go up here. Then we have -6 goes to 5, so it's going to go up here. And then we have -7.5. It's going to go up here, and then it's going to be paired up with 2, so it's going to sit right here. And our -6 goes with +1, so it's going to sit here. And so we're ready to sketch the graph. Okay, if you notice, our domain for this would be all values greater than -8. Anything that goes to the right. Well, our range for this would be this graph is going to go towards infinity upward and towards infinity downward. So that would be all real numbers. So I'm going to go ahead and write that information up here. And please take note that this kind of graph is not a function because this graph, when we test it using the vertical line test, it's going to touch this pencil twice. So this is not a function. Did you get the same answers as this? Good. Perfect. If you find this video helpful, hit like and subscribe for more math videos. See ya.